This is section 1-2, measuring and constructing segments. These are the objectives: use length and midpoint of a segment. The second one is construct congruent segments using a compass and straight edge. This is the vocabulary. By the end of this lesson, you should be familiar with these terms. You can pause to read them. I'm going to move on to the next slide. This is postulate 121, called the ruler postulate. You can read what is there, but basically what this is saying, given any segment, you can use a ruler to find the distance. Let me read this to you. The distance between any 2 points is the absolute value of the difference of the coordinates. This is more like a definition. If the coordinates of a point A and B are lowercase a and b, then the distance between A and B is. So this is what the definition is talking about. You have this distance, so if you want to find the distance between these 2 points, you take the value, lower cases, and find the difference and take the absolute value. You can go backwards as well. The distance between A and B is also called the length of A and B. Moving on to the next slide. Practice says find each length. Part A says find the length xy. So here's x, here's y. We're going to find the distance. Apply what we saw in the previous slide. So all we need to do is find the absolute value of the value of x, the value of y, 1/2, 5, subtract, a little bit of pre-algebra here, and then take the absolute value and you end up with this. Same manner, B, you need to find distance of xy. Use what we know from definition from the previous slide, and you end up with 4.5. You should know how to compute this. Find the absolute value. 4.5 is your answer. Next slide. Let me read this to you. Congruent segments are segments that have the same length. In the diagram, PQ is equal to RS. Talking about this picture here. So you can write PQ congruent. This little symbol means congruent. Right here. And since we're talking about segments, we use the segment symbol on top of the letter PQ and on top of the letters RS. Let me just continue. This is read as segment PQ is congruent to segment RS. This right here. This is important. The tick marks, these little tick marks, these are used to in a figure to show that there's congruent segments. Let me read this to you. A construction is a way of creating a figure that satisfies certain geometric principles. We're going to cover one in the next slide. A geometric construction is made using a compass and a straight edge. Practice says construct the segment congruent to MN, and we're going to be using a compass, a straight edge. Since this is a video lesson, you have to kind of imagine how we're doing this. But you should be able to follow along the illustration that I'm providing you here. Step 1 is use the straight edge to draw line L. So here's line L. And then you're going to draw point S. This is step 1. Step 2 is use a compass to measure the distance between M and M. So compass, place the pointy side here, the pencil side here, find that distance, and then it should look something like this. Pointy side, the pencil, or vice versa, doesn't really matter. No, actually you do want the pencil on the other side. So you place the pointy side here, the pencil on this side, and then you draw an arc. Place a point on the compass at S and make an arc through L. Once you have that, you're pretty much done. A ruler will demonstrate that ST from here to here is approximately the same length as MM. Next slide. Very important postulate. Postulate 122. It has a name, segment addition postulate. I'll read it to you. If B is a point between A and if B is between A and C, then AB plus BC is equal to AC. If you look at this picture, if you add this segment plus this segment, it should equal to the entire segment. This is what this is saying. Let's do a little bit of practice here. It says y is between x and z, and they're giving you this information. xz is equal to 3, and xy is equal to 1/3. They want you to find yz. I mean, I can draw a picture so you can see this a little bit better. This is a segment. You have x and z. Xz, the whole thing, is 3 units. Xy is, since y is between x and z, I'll put it somewhere here. So that's why we have xz, which is the whole thing, is equal to xy, this portion, plus the second portion of this segment, yz. And we're applying the segment addition postulate. So what we're going to do is we're going to substitute. We know that xz is equal to 3. Plug it in here. Xy is 1 1/3. This is what we're looking for. We leave it alone. Do a little bit of pre-algebra, more of algebra, and then you end up with yz is equal to 1 2/3. Next slide. I clicked one too many, but anyway, it says practice using the segment addition postulate. M is between n and O, find NO. So using the segment addition postulate, this is what you have. NM plus MO is equal to NO. Applying the postulate, next thing is basically going to be to substitute. NM we know is 17, MO is 3x minus 5, the whole thing is 5x plus 2, and we're going to do a little bit of algebra here. I'm just going to go a little bit fast with this. Take away combine like terms from the left hand side, take away 2, simplify, take away 3x from both sides, 10 is equal to 2x, divide both sides by 2, and then you end up with x equals 5. Don't stop here, you're looking for NO. How do we find NO? We know that NO is 5x plus 2, so we do the following. Substitute it into the algebraic expression, and that's how you get NO is 27 units. Number 5, more practice, says E is between D and F, find DF. If you apply the segment addition postulate, this is what you have. Substitute, a little bit of algebra, which I'm going to skip. I'm sure you can do this on your own, but you should agree with me that you get x equals 4. Once you have x equals 4, do not stop here, because you don't want the x value you're looking for. I mean, you need the x value, but they want you to find df. So go back and substitute it for what df represents here, which is 6x. Plug in the x, and that's how you end up with 24 units. Let me just read this to you. The midpoint M of AB is the midpoint that is the point that bisects or divides the segment into two congruent segments. If M is the midpoint of AB, then we have AM is equal to MB. Let me give you this little picture here. So again, M is the midpoint of A and B. We can apply the tick marks. So AM is equal to MB because M is the midpoint. And moving on to the next slide. Practice using the midpoint idea. Says D is the midpoint of EF. They're giving you that ED is equal to 4x plus 6, DF is equal to 7x minus 9. And they want you to find those three distances, ED, DF, and EF. So using the midpoint, the fact that D is the midpoint, I know that ED is equal to DF. Again, you can use the tick marks. At this point, we substitute. You don't use the segment addition postulate here. You use the fact that AD is equal to DF because D is the midpoint. Substitute, solve for x. You can do the algebra. I'm not going to bore you through the steps, but you should get x equal 5. And do not stop here because the problem is asking you to find ED, DF, and EF. So you go back and you plug it in for ED, you plug it in for DF, you get 26, 26. You can actually skip going through the algebra here. Why? Because ED is going to be the same thing as DF, because D is the midpoint. And just avoid this if you like. And then the last part, how do we find EF? You don't have to go through the algebra, just multiply this by 2. And that's how you end up with 52. Here I just showed you the algebra. Moving on to the next slide. It says M is between N and O. O is equal to 15. M and N is equal to 7.6. Find NO. You can pause, because I'm not going to show you the work. I'm just going to give you the answer. Once you go through the math, applying the segment addition postulate, this is what you should be getting. M is not necessarily the midpoint. It's just M is just between. Make sure that you understand that. Big difference. And in the last one, it says S is the midpoint of TV, and they're giving you that TS is equal to 4x minus 7, and SV is 5x minus 15. They want you to find TS, SV, and TV. I'm going to ask you to do this practice problem. So go through the math, pause it at this point, and this is what you should be getting. 25, 25, and 50. This is the end of lesson 1, 2.